Hey guys, in the last voxel video we talked about what impacts the performance of the voxel engine, and that's the generation of a mesh, it's the uploading of a mesh, and it's the rendering of this mesh. In the program I showed you in the last video, all these tasks are performed on the same thread, and you can see that on the FPS. Here's a short clip of that program running. You can see that it's running at about 25 FPS. The reason for this is that we remove a new block every single frame, and it's just the worst case example for this program. What I've done now is making the mesh generation happen on a different thread. So let's see how that impacts performance. We can see that it's a bit better, the FPS is a bit higher, but it doesn't feel like the FPS is a bit higher. So what's the reason for this? Well, we got these lag spikes that are happening. We're not doing any logging, so we can't confirm this, but it's the lag spikes. But it's not the generation that's causing these lag spikes anymore, because that happens on a different thread. So now it's the next point on the list, and that is the uploading of the mesh. That has to happen on the OpenGL thread. So what can we do to optimize this? We can try to make the uploading faster by having less data to upload. So let's go into the generation code and see if we can optimize it a bit to generate less data to upload. Okay, before we do any optimizations, I just want to note that I made these logs that we can look at how performant the program is, so we have something to compare to. I have these two lines inside the mesh worker, and then inside the voxel screen we also log how long it took to upload the mesh. Let's have a look at the performance then. Right, we still get about 250 to 60 FPS. It still doesn't feel fast. Okay, let's look at our output here. Okay, so these two lines get executed on the thread that is generating the mesh. So this construction time for the mesh we don't really have to take into consideration, because this is time on a different thread. But the amount of floats that we have to upload, we do have to mind, and right now it's about 5 million floats every single time, taking 16 milliseconds out of the main thread's time to upload. So let's see if we can do any better than that. So I just implemented this really simple optimization where you just only make a face for a block if there's air next to it, and only if there's air, or there is no block next to it because it is on the edge. That is this case right here. But if we do that, if we make that optimization, we get much better values, both for the FPS. The FPS is much higher now, and we also get a lot better number of floats to upload. In this case we got just under 1 million, and I believe we got 5 million before, so we cut it in more than in half. This is just a fifth of what we had before, and for every frame there's a block removed, so that means a lot more faces every single frame. If I just go back to the first first mesh we constructed here, the completely filled out mesh, we only get 261,000 floats. That's not a whole lot, and it doesn't really matter about the milliseconds for the construction. And even if it did matter, it didn't even increase that much from earlier. I believe actually this is a lot, not a lot, but it's a bit faster than it was before. So I don't know if we're skipping some of these buffer operations. Maybe that's what's causing it. I don't know. This is faster all around. That is great, and we get a nice FPS of 600. I've also got some other stuff running. I got over 1,000 on my other tests, but that is great. That means the engine is pretty fast. That's cool, man. Oh, and also when this optimization works, we can go inside the cube and we can see that it has completely been hollowed out. all of the faces are gone. That's nice. If you want to check out the code, I uploaded it all to GitHub, so now you can browse the code by yourself. If yeah, I realize this video is a bit hard to follow, and so now you can run it yourself if you're interested in voxels or meshing.